Hey, chipperdoodles here, and I'd like to say if you haven't checked out the Anwar overview slash intro, um, check over and go ahead and give that a quick look just in case you're in the dark about the whole thing. This video is specifically the Anwar Amulet, which is a subfamily, um, one of at least three so far. Um, so with Anwar, I mentioned that there's subfamilies and they all share certain commonalities, but might differ in details, and each one is kind of separated by a physical, um, different physical shape, basically. Okay, so getting back to the amulet, that's this guy right here. Um, these are 36 millimeters in diameter. Um, And like all the other Anwar boards, they have 4 millimeters between board height. Um, they consist of two parts: a baseboard and a faceplate. You can see I have different faceplate examples, and faceplates, like all Anwar, are meant to be swappable. So you can just here this one, you can just pop that off. That just went flying. Sorry, and then snap another one in place, and then when you're happy with the one on board, um, you can secure it, fasten it down with just some M2 screws. So in that case, here, pop this guy off and give you a look at the inside. Um, with the inside, we'll give you a more technical spec. The brains, the heart, the I don't know which you would consider which, but I guess if you're crunching numbers, the brains is an A-Tiny 1616, which is one of the 1 series A-Tinies that came out in the past. I want to say like 2017-ish is when the 1 series officially was announced or launched. But these are really, I think, a big step. From the previous generation, a lot of nifty things that kind of made this project even more possible, just due to sheer convenience. So speaking of the convenience, let's see. So A-Tiny 1616 here is broken out via a 10-pin header. You can see on the back side of these, male header. I chose these sizes, or these specific Samtech headers, because of their low profile height, and their pitch I think is big enough to be hand soldered compared to, oh gosh, like a Micro's or Hero's little header that you'd find on Edison boards or newer CM modules and stuff. But these give me that nice low profile height of 4 millimeters between boards, and they mate nicely. And I think, depending on your solder skill levels, these are still very hand solderable. So you'll find these Samtech headers on all family subfamilies of Anwar, just in different pin counts depending on the board. Okay, so this is actually what's cool, is I managed to one of the timers, TCA0, has 6 channel outputs, and so I've broken out all 6 onto this header. So that means you can have a possible, at most, 6 PWM lines on your faceplate design. So if you want 6 individually PWM'd LEDs on your design, you could do that. And also, though, alternate pin functions, 2 of those, if you don't need all 6, you can use 2 of those for the I2C data and clock line. So if you want, you could probably throw a I2C sensor or something on there. Bear with me. Just kind of doing this live and rehashing, so sorry for the pauses, but okay. There's also 5 of those 6 pins also are analog in, so if you have an analog sensor or something, or want to do something cool with that, you could do that. And then the other pins are power, ground, CFG, which I'll talk about in a second, and UDPI is like a backup programming. So these guys, as designed now, are actually programmable over the USB port. The USB port is connected to a USB UART. Here you can see a CH340E. And a couple of passives turn this into a UDPI programmer. So you don't need to worry about bootloaders or anything. You can hook this up, use MegaTiny Core or Pi MCU programmer, and just program your ATiny. It's super nifty and convenient. But just in case, for reasons, I have the UDPI broken out. So that's kind of the ATiny kind of part, and we'll move to the second big part, which I guess this is the heart, since it's the flow of energy, controlling the flow of energy. We have an LDO that just drops the USB voltage to give it a charge of this 15 farad 2.8 volt hybrid capacitor here. It's a very interesting, these Vishay HVC NE caps are very interesting hybrid caps. I haven't really quite found much that behave like them, and they've offered kind of just the sweet spot in terms of energy density, flexibility with charging. You know, it doesn't, compared to a NiCad, it charges super duper fast. Compared to a lithium ion, it is, you know, it'll 100,000 cycles versus, you know, lithium ion in the hundreds to, you know, thousand at most cycles. So, and just in case that word is confusing you, it's just a charge to depletion. That's a cycle. So these are kind of intended to be, you know, charged on the regular and used on the regular. Your mileage will vary based on your sketch and your faceplate design, depending on how much the power draw is. So these are really good. I could do a whole video on them probably. Like, they've enabled me to stay in such a small package size. But that being said, Anwaar is flexible enough to where if you can fit something within the design requirements, you can design your a future baseboard, your own baseboard. Let's say I want to use a tiny coin cell. I want it, like, if you can fit it in there physically, and all the specs are there for you to match, you can design a compatible baseboard if you want to look at something else. I'm always on the lookout for newer energy storage tech. Seeing what happens with the tiny solid state batteries and how much power they can provide. But for now, these have been wonderful. They've kind of got a weird elasticity to them, but for a daily charge and run, they've been great. For some numbers, if you're curious, let's say all the power on the Amulet baseboard is boosted, so it's under a constant load. With regard to, like, something's always drawing on it. It has a skip mode, so it's not constantly a heavy mode. It could be a very light load, depending on the downstream load. But depending on your overall draw, I'd say anywhere between, and your state of charge, which is important. Like, if you leave this on overnight, have like a light sketch that draws, you know, 1 to 2 milliamps, you're probably gonna get maybe six to 8 hours of runtime, which I think is pretty good for a working day. Now your mileage may vary, like I said, state of charge, whatever faceplate's running in the draw, is pretty good. So like at least 5 hours, I would say. And like complete charge versus quick charge. Complete charge I'd probably consider around 3.5 hours, but a quick charge from 5 minutes to like 40 minutes, you know, is also something I haven't tested as much as I want to. But anyway, so pretty simple circuitry. What's also really neat is this maximum boost regulator I have has a single resistor configuration. So if you guys design electronics a lot, sometimes they'll have a resistor, a voltage divider to determine the output voltage. This one, you just need one resistor and it chooses from a bunch of presets. And the nice thing is, if you leave it open, which means not connected, if you leave it floating, it just defaults to 1.8. And once it's turned off and you plug a value in, it'll read the new value. So it's not as iffy as working with something that expects a constant resistor divider there. So that being said, the CFG pin, which I mentioned earlier, is actually a connection to the faceplate to put your configuration resistor. Now, default value I usually do is 133K, which gives you 3 volts out. And note, this is a boost converter. So the boost converter operates from 0.8 volts cold start to I think max in is 5.5 volts. But when it's running, it can run down to 0.4 volts. But I usually find that these caps, under load, you'll start losing power around, 2 to 1.8 volts. Not enough to sustain a constant heavy load. But that being said, it's a boost only. It's not a buck boost. So if you want 1.8 volts, it'll actually just kind of be like a pass-through in slash kind of a resistive load thing, which sometimes you might actually get a longer life selecting 1.8 volt than say you're just powering red LEDs. Anyways, I'm rambling. The point is, the faceplate determines the output voltage due to the nice single resistor configuration here. So that means I could have a design like this cat with red LEDs that I want to run at 1.8 volts or 2.3 volts, but I can have this guy with white LEDs that I want to run at 3 volts to give a decent amount of light. That way you don't have to change anything on the baseboard. The configuration's all depending on the resistor. Let's get R1 here to configure CFG. So I think it's nice, and this Maxim regulator really made it easy to do that. So if you're curious why, but that gives flexibility in design, because if I hope I mentioned it in the overview, the whole idea is not just to sell my own designs. I want people designing stuff for the baseboards. I want to see what cool, creative things you can do. Like, these are just samples of what I've done. A little personal Arabic design here, a silly Memento Mori Dark Souls reference, the IWW cat, and then this one, which actually here I'll show you this one. So for those of you who watch cartoons might recognize, this is the light glyph from Owl House, and here is which is something they physically draw, and they tap on it and they light it up. So here's the switch that controls the boost output. And in this sketch, this one I actually have programmed to run for this guy. I have a little touch surface hidden underneath there that I don't have any fancy programming right now. It's just a simple on-off. But you touch it and it lights up. So more about touch, since this one specifically uses touch. It's kind of funky. So the 1 series A Tinies have a peripheral touch. They have PTC, peripheral touch. What's the C stand for? Anyways, it doesn't matter. I can't remember. Anyways, it has a built-in touch peripheral. But the caveat there is the libraries aren't open source. They're free to use, but not open source, so it gets really annoying when you try to do things with Arduino. So my little asterisk is these are touch capable, but you'll have to find ways to use the library, whether you're using Microchip's official Microchip Studio or what's MP Lab X or whatever, which I used Microchip Studio, but I think they're trying to transition to MP Lab and see. But so that's the caveat. So you can't do touch in Arduino, at least the peripheral touch. You can design your own touch circuit that's compatible with an Arduino library and do it that way too. But that's my little asterisk. So the whole idea is you can make personal, meaningful tokens, order them up, build your own PCB. These are relatively simple to hand solder. I chose 0603 components, but you can go, 0805 and whatnot, whatever your comfort level is. And the great gifts, little tokens. I love bringing them around, just kind of feeling the surface, playing with them like that. So this is the Amulet overview. I hope I gave a decent amount of information. If you want to know more, just hit up comments, check out the docs, you message me. I'll super excited to share and fill you in on more. So that being said, this is the Anwaar Amulet. This is chipperdoodles. I hope this was informational. I know I tend to ramble forever, but that's just me. Okay, y'all stay cute. I'll catch you around.